All right. So, hello everyone. How are you all? I hope you are all doing wonderful. So, today again we are back again on this auspicious event, right? So, today is a festival of color. So, I wish you all a very happy Holi, right? So, we are live again on this particular occasion still. So we will be discussing today again, as we have already started the series of JEE Mains previous year question discussion, and in these sessions we are basically discussing each and every chapters of maths, right? So we started with the conic section part. As of the previous lecture, we have already covered this straight line, right? So now and after that, we started with circles, parabola, hyperbola, and ellipse is already covered, right? So in the conic section, the last part is basically that of the hyperbola, which is basically left to be covered, right? So today in this particular session, we will be seeing the important previous year problems of hyperbola, and I will show you that the questions are not very difficult. Those are basically very simple problem, just involving these basics of the geometrical properties of the points on the hyperbola, right? So with that, we'll basically discuss those questions and we'll see that those questions basically involves around the calculating the initial points. That is a very important question. Secondly, the questions involving the tangents and normal is also really important, right? So we'll be discussing each and everything in step by step, and along with this session we'll be also discussing about some of the important questions that is very important for your upcoming JEE Mains examination. I have done some kind of a statistical analysis, and based on that analysis, I will be able to answer that particular question of you, right? So if you have any question, you can please ask me, or else we shall start, right? So, and if you want for a personalized one-to-one interaction and want to get your doubt clear, you can definitely do that. So if you go to the description of this particular live session, you'll find the contact details of that undersigned, right? So you can definitely contact on that particular number, and we can basically start for a one-to-one personalized mentorship sessions, okay, where we basically discuss more on your personalized doubts and help you to cover up the syllabus, right? And these particular sessions are all free of cost. They are basically available on YouTube. It is basically you can watch this particular session so that you prepare for this upcoming examination, right? So if you have someone who have already finished this syllabus and you have already done quite a good revision of your short notes, then you can basically move with this particular chapter of hyperbola, right? So let me tell you quickly some of the statistical analysis that I found out, that mostly in the chapters of conic sections, the concept of the concept of tangents and normal are really important, right? And the interesting part is that now these concepts are very easy, right? So if you are able to take the parametric point on a hyperbola or a ellipse or a parabola or any of the conic section, then you can definitely write the tangent and the normal equations simply, right? So in the chapter of applications of derivative, or that we call as short form AOD, so we have already learned that the slope of the normal or slope of the tangent is simply given out as the slope of the tangent is simply given out as by the differentiation, the first derivative of the function at that particular point at where I'm basically calculating the tangent at, right? Now similarly, we can also find out the slope of the normal by calculating 1 minus times of 1 upon the first derivative of that function with respect to x at that particular point. Now with these two information, we can simply find the information about the tangents and normal, right? Now that is a very important problem. Secondly, you have to basically also discuss about the basics equation, okay, basic equations and the distances, okay. Now that is also really important, basic equations and distances, right? Now what I basically mean by basic equation and distances, so in this chapter of this hyperbola, you will find out that again, similar to this ellipse, hyperbola will also have two directrix and two foci, right? So therefore, you have to basically understand how to calculate the distance between two important points. Along with that, you will also need to calculate the distance of a point of any general point on the conic section from the focus, right? Those are basically called as a focal distance, right? Now that is going to be really important. Now the interesting part of for hyperbola, especially for the case of hyperbola, is that in hyperbola you will also have a specific type of hyperbola. Those are called as rectangular hyperbola, right? Now why it is special, I will talk about in this particular session, but before I move to that, you have to also understand that unlike the any general conics, hyperbola will have two branches. Now very first of an important misconception that basically arise among students, they basically think that one of the branches of the hyperbola is basically a part of a parabola. That is totally wrong, right? Because hyperbolas are generated from that doubly conics, right? So if I tell you that what if you have someone who already discussed about that, then it is fine. Otherwise, right? I have already discussed that in our initial lectures of our conic section discussion, but it is interesting to know that all the conic section, all the non-degenerate conic section that you're basically seeing in chapter of parabola, hyperbola, ellipse, those are basically non-degenerate conic sections, right? So non-degenerate conic sections are basically obtained just simply by cutting the plane. So what I do over here is basically, if I take a plane and I just cut it over here in this fashion such that it not passing through this midpoint, and if I cut it, I will get two branches like this way, right? I will get two branches, right? And this is how we obtained a hyperbola, right? Is, and for parabola, this does not intersect the two of the doubly conics. Instead, it basically will be like this, right? So those particular things are totally different among each other, right? So it is like this. So parabolas and the branch of an individual branch of an hyperbola are totally different things. Now that is a very big of a misconception that people must avoid having that in their mind, right? So if you're someone who is starting this chapter for the first time, I would say definitely, please, first of all, it is always necessary to go through the basic textbooks, right? So I would obviously recommend NCRT and NCRT exemplar, right? So please go through the NCRT and NCRT exemplar, and then you can move on with this particular previous year questions, okay, over here. So that will actually help you to understand the entire session nicely, okay? So you will see that not very difficult problems are asked, the questions are little bit tricky. Now that particular part of the trick has to be developed over the time. Now for that, I am basically here to help you out with that particular preparation, right? So, and also another very important differentiation between parabola and hyperbola is that for hyperbola, you will see that the eccentricity is always greater than 1, right? And for a parabola, the eccentricity is basically equal to 1. And for the case of, so let me write it over here. So this is for the case of parabola, and this is for the case of hyperbola, right? And also for the case of, and also for the case of ellipse, and for the case of ellipse, so ellipse is basically obtained by, if we are, so sorry, this particular part, when the plane is having intersecting it, but it is having some angle, it is basically kind of an ellipse over here, right? So parabola is basically formed when this particular plane comes out, okay? So it doesn't goes out of the conics, right? This is basically how the parabola is obtained, okay? Please pardon me for this particular part, but I hope you try to understand what I'm basically trying to mean. Is basically when you're putting the plane and cutting it perpendicular to the axis of the conics, okay? So let us call this is the axis of the conics, or so if you're cutting the conics, this particular oblique conics with a plane which axis is parallel to this conics axis, right? So then you basically, and but you're shifting it with the sum of a particular eccentricity, right, or a shift from the midpoint, then you're going to obtain a hyperbola, right? That's how basically you obtain it, right? And for the case of an ellipse, you will have the eccentricity to be less than 1 and within 0, right? So this is all the information that you need to know in order to discuss about the chapter. Also, I have also already discussed about in the previous sessions, that is, if I take any point on the conics, let us call it as P, right? So, and for a conics, it is very important to define the focus. It is important to define the focus. Let us call the focus as alpha comma beta, and the directrix, right? And let us call the directrix, and let us call the equation of this directrix is ax plus by plus c is equal to 0. So any general conic section is basically a simple ratio of distance that is basically defined as eccentricity, right? So eccentricity is defined as our distance of the focal distance of any point divided by the perpendicular distance of that particular point from the directrix, and that's how we basically generate any general conic section. So today our goal is basically to discuss about this particular part. Also mostly we will focus on the hyperbola part, right? So our goal is basically discuss about the concept of conic section, previous year problems, as well as to practice both numerical and MCQ based problem. We'll also try to understand some of the JEE advanced integer based problem also, right? Which is very useful for your upcoming mains exam. You will see that if you practice the JEE advanced integer based problem, many of the cases it is very likely to have that those questions directly come up as it is in that mains paper, right? So that will be a very bonus point for the persons who are basically have completed that particular preparation of the JEE advanced integer questions, okay? So with this part, let's start for our discussion on the chapter of hyperbola. So here we have our first question on the screen. So I would love all of you to please give it a try. Please give it a try, okay? So this will actually help you to try to understand the problem nicely. So let us try to read the problem again. As like that a case of an ellipse, hyperbola will also have two foci, right? So therefore, it is saying that the hyperbola the hyperbola is having the two foci. So let me try to draw and explain you the hyperbola looks like. So this is basically, so whenever we have the general equation, the standard or the general equation of an hyperbola is basically like this. So that is x square by a square minus y square by b square is equal to 1, right? And when our a is greater than b, again the major axis is basically going to be the x axis, right? So that is, let us take the general case when a is greater than b. For this case, this particular point is a comma 0 and this particular point is minus a comma 0, right? Now for this case we will have the focus, first focus at ae comma 0 and the second focus at minus ae comma 0, which is very similar to that of the ellipse, right? All right. So this particular part, I hope this is clear to all of you, right? Now it is said that the focus of the hyperbola is basically given as 1 comma 14 and 1 comma 12, right? So if you just look at the way the coordinate is defined, so then I am getting the feel that, so if I try to draw the x and y axes, so it is always special to draw the x and y axis and then try to plot the point of the focus. So it is saying that 1 comma 14, which is basically like this, 1 comma 14 and 1 comma minus 12 are basically given as the focus of the hyperbola. So this particular thing and the focus will always lie on the major axis. So in this case, the major axis is not the x-axis. Instead, the major axis is going to be is parallel to the y-axis. It's not the y-axis, but it's parallel to the y-axis, right? So in this case of the hyperbola, I will have a shifted vertex as well as, so therefore this will be of the form x dash square divided by small a square minus y dash square divided by b square is equal to 1, where our b is greater than 1, right? B is greater than a, right? So this is what the form of the hyperbola will look like, right? So also, so from this particular case, you will try to understand that this is the focus of the hyperbola. So let us try to draw the branches of the hyperbola will be something like this, right? And this is the point of intersection of it, right? Now if I try to find out, what is the midpoint of this vertex, what is the midpoint of this axis, the foci, right? So you will see that the midpoint of the focus is always going to be at the vertex of the hyperbola. So in this case, our midpoint of these two focus, so I will just use the midpoints and let us call this vertex. So our vertex is going to be equal to 1 plus 1 by 2 comma 14 minus 12 by 2, right? So that will generate that will definitely generate me the midpoint, right? That is going to be equal to 1 comma, 1, right? So I will going to have the vertex of this hyperbola at 1 comma 1, right? Now if I have the vertex, our next goal, it is also said that the hyperbola passes the point 1 comma 6. So 1 comma 6 is like this, right? So it is basically the one of the point where this hyperbola is intersecting, right, at the major axis, right? So therefore I basically have all this information. Now our main task is to understand, now in this case when the foci are given but the major axis is along the y axis, so in this case the distance between the foci is basically given as 2 times of b into e, right? And this particular distance is basically over here, it is given as 20, it is basically given as 26, right? So from here you'll get the value of b is equal to 13, right? So you have one more equation involving the value of b and the eccentricity, right? Now I also know one important information, that is, it is said that I also know one of the very important information, that this particular hyperbola is intersecting the major axis at 1 comma 6. So 1 comma 6 is basically, so for the case when the major axis is basically the y axis, the hyperbola intersect the major axis at the point 0 comma b and 0 comma minus of b, right? So over here, since the hyperbola is shifted by, and it is at the point of the line y x is equal to 1, because it is shifted from the y axis, so major axis is y x is equal to 1. So this particular point is going to be equal to, this particular point will be equals to 1 and 1, right? And we will have the information about this point b, so b is equal to 6. So we have also the information about b, so b is equal to 6. And once we have this information, we also know one of the very important information about the eccentricity. So eccentricity in case of an hyperbola is basically given as square root of 1 plus b square by a square. Now it is always true for all the cases, right? So therefore from this case we can also write a square is equal to b square e square minus 1, right? So therefore, which also can be written as BE whole square minus B square, right? Okay. Now from this particular case, so okay, there is a one mistake I did. I just put B is equal to 6. B should be equal to 5, right? Because our vertex is also at 1 comma 1, right? So this particular distance is equal to B, right? So from the vertex is not from the y is equal to 0 line. It is from the y is equal to 1 line, because our center of the conics is basically at 1 comma 1, right? In this case, the origin is the center, but in this particular case, it is 1 comma 1, right? So from here, you'll get the value of B as equal to 5. And once we put that information over here, I'll get the value of A square as basically 13 square minus 5 square, and that is going to be equal to 144. So from here, I'll get the value of A basically equal to 12, right? Now you must be wondering, like, why does this particular thing happen? That is A equal to 12. So A is greater than B, right? But the interesting part over here to understand that when the hyperbola has the major axis as the parallel to the y-axis, so the equation changes to the form of minus ax square by a square plus y square by b square is equal to 1. Also, you can write this a square minus y square by b square is equal to minus of 1. That is also fine, right? So that is something that you have already learned that as a part of a basics, right? So it is not that thing that a should be greater than b in order to the x-axis to be a major axis. So I should not write it very specifically that a should be greater than b, right? Now I hope you understand. Now why I took the case that a should be greater than b, because it is unlike the case of the ellipse. It is not the case of the ellipse that a should be greater than b. Then I will have the major axis as x-axis. Otherwise, the other way around, right? But in the case of hyperbola, it is not like the same. It is not like the same. It is when we are having, so if we are having the coefficient of y square as minus, so you can understand, like I will tell you how to understand this particular part. That is something called as symmetricity, right? So if I just replace this value of x with minus y minus of x, so I am getting this particular hyperbola is symmetric about this y axis. Similarly, if I replace it about y, I am also having the equation symmetric about the x axis, right? That is will going with the symmetricity of the case, right? Now to understand, so if I just shift this position of negative over here to here, then this will become the case when the hyperbola will be like this, right? So this is what you have to understand over here in this particular problem. So it is not the case of that of an ellipse that a is greater than b, you will have the major axis and minor axis, right? So that is something that you need to remember. So generally what you will understand is that mostly you will be encountering the case when x square by a square minus y square by b square is equal to 1. That is the general case that you're going to understand in most of the problem, right? So with this part, we got the value of a, right? Now, once we have the value of a, I need to find the value of the length of its latest rectum. So for this case, the length of the latest rectum, is going to be equal to, so length of latest rectum is going to be equal to, so it is basically having the major axis as the parallel to the y axis, so it is going to be 2a square by b, right? So you just put the value, we are going to have the value as 288 by 5 units, right? Which with this we will have the answer as option number C with this particular problem, right? So I hope this particular problem is clear to all of you. This problem was nothing but just the basics of the distances of the important points of a hyperbola, and once you understand the geometry of the hyperbola, you're basically easy to go and proceed with the problem, right? So there was nothing difficult except the part that to try to understand or find out the points or the particular location of the point with respect to the x and y axis, and once you get that, you're basically good to go with this question, right? That is what you have to understand over here. I hope this is clear to all of you. Please let me know if this is not clear or not. So I hope this part is clear to all of you, right? If some of the part is not clear, you can definitely let me know in the live chat, okay? So I will be looking through your questions. You can always let me know. All right, so let's then go about with the next problem. So with the next problem, we have again an interesting problem. So I say that the questions are not going to be difficult, rather they are going to be tricky, right? So some people who have prepared the concepts very nicely from the basics, they are going to do well, very well in this particular set of exam, right? So it is said that let the focus of an hyperbola H, right, coincides with the focus of the ellipse that is given as x minus 1 whole square divided by 100 plus y minus 1 whole square divided by 75 is equal to 1, right? So for this ellipse, let us try to first of all find the eccentricity. So for this particular ellipse, the eccentricity is going to be 1 minus 75 by 100 square root of that. So from here, I get the relation as 1 upon 2. So eccentricity of this particular ellipse is coming out as 1 upon 2. Now if I have the, now since this ellipse has shifted origin, so instead of having the 0 comma 0 as the origin, this particular ellipse is basically having 1 comma 1 as the origin, right? So it is basically going to be like this case. So pardon me with the diagram actually. So let me try to draw it maybe like this. Okay. So please don't go by a diagram, okay, but try to understand why I'm basically trying to draw it to explain you the parts, right? Now this particular distance is going to be equal to square root of 75, right? Square root of 75, and this particular distance is going to be equal to 10, right? So from here, let us try to find out the focus distance, okay, or let us find out the focus. So our focus S1 and S2 are going to be on this particular axis only. So this particular axis is basically y is equal to 1. So our focus will be always on the line y is equal to 1, right? So I'm putting it something comma 1, right, as the 2 for the focus, and the value of x I have to find it out. So the value of x, so distance of the focus from the vertex is basically equal to AE, that is the distance of of origin to, so this origin is basically, let us call it center, okay. So distance of the center to the focus of an ellipse, to the ellipse is basically given as AE, right? So that is basically AE is going to be equal to, so our A is 10 and eccentricity is half of that. So 10 by 2 is basically going to be 50. So this particular distance is can be equal to 51 comma 1, as well as it can also be minus of 49 comma 1, right? I hope you can understand this particular chart over here. So this is going to be the two of the foci of the ellipse. Now it is said that these two foci are the same as that of an hyperbola, right? So it is said that, and the eccentricity of the hyperbola be the reciprocal of the eccentricity of the ellipse. So from here we can also find out that our eccentricity of the hyperbola is going to be equal to 2, right? And this is the eccentricity of the ellipse, so I'm putting E of capital E, that is ellipse, right? So from these two parts you will understand that you have this given information about the hyperbola as well. So let us try to find out the value of A. Now similar to the case of an hyperbola also, the distance AE basically represents the distance of the center of the hyperbola to the focus. So that is also going to be equal to, so that is going to be equal to, so from this part we have to also understand that, once we have the, oh, did I make any mistake? Oh, sorry, very sorry. That AE is basically equal to 5, not 50. Extremely sorry. So AE is equal to 5, not 50, right? So let me erase this part. So this is going to be, yeah. So this is going to be equal to 5 comma 1 and minus 4 comma 1, right? So that are the two important points that I basically have it over here, minus 4 comma 1 and, sorry, this is going to be 6 comma 1, right? 6 comma 1, right? So these are the two important points I will have, 6 comma 1 and minus 4 comma 1 as the foci of the ellipse, and this is the same foci as of the hyperbola as well. So for the hyperbola also we have the foci at plus minus AE, right? So plus minus AE, and those are basically at 6, right? So plus minus AE, they are also at basically 6 comma 1 and minus 4 comma 1, right? So what I will do over here, so let us try to find out the distance between these foci. So S1, so in this case, the S1, S2 is basically equal to 10, right? So if this particular thing is equal to 10, similarly for the case of an hyperbola also, this is also equal to 10. So from this case, I will get the value of A for the hyperbola as equal to 5 upon 2, right? Very simple. So I will get the case of an, so let us first of all assume the equation of the hyperbola also over here. So otherwise it will be difficult. So hyperbola equation, so I'm putting it x, since also it will have the same foci, so it also has the same center. So it must be like x minus 1 whole square divided by a square minus y minus 1 whole square divided by b square is equal to 1. So from this case, we have the value of a as equals to 5 upon 2. And once we have the value of a, we can also find the value of b, because we know that for the case of an hyperbola, a b square is equal to a square into e square minus 1, right? So from this way, we can also find the value of b, and b square, what I'm getting is basically as 75 upon 4, right? You can just put the value back into this equation. So from here, you'll get the value of b as square root of 75 by 2. Right. So once we have A, once we have B, now we have to find out that if the length of the transverse axis of the hyperbola is equal to alpha. So what is the transverse axis length? So transverse axis So length of transverse axis is going to be length of transverse axis is equal to 2a, and length of conjugate axis, and similarly conjugate axis is equal to 2b, right? So once I have, so equal to 2b, and this is given in the problem as alpha, and this is given in the problem as beta. So this is given as beta. So I am getting the value of alpha. I'm getting the value of alpha from this case as 5, and beta I'll get it as value as square root of 75, right? So I have the value of alpha, I have the value of beta. So I need to find out that the value of 3 times of alpha square, 3 times of alpha square plus 2 times of beta square, and that is basically equals to, so from this I will get 3 into 25 plus 2 into 75, which is basically going to be equal to 75 plus 150, that is going to be equal to 225. That is going to be equal to 225. With this, I will have option number A as my correct answer from this question. I hope this part is clear to all of you. Please let me know. So, were you able to solve this or not? Please let me know. So, this part was very simple, right? We just need to find out the important points, and then once we find out, the question is really straightforward. So, from here, we will see that the parabola will be like this case, right? Having the same center, right, like this. So I hope this question is clear to all of you. Please let me know if this is not clear or not. So I hope you are enjoying the sessions what I'm taking up till now. Okay, and if you are new to this particular channel, please don't forget to hit the subscribe button, and please click on the bell icon so that you don't miss out any upcoming notification of the content. Okay, so we are going to come out daily live, and we are going to discuss about some of the important concepts and chapters for your JEE Mains part, right? So in this particular duration, what we have with us, we are going to discuss about all the important topics, and we are going to discuss mostly on the previous year problem, so that you are actually getting ready for your upcoming JEE Mains exam. Now, mostly in the JEE Mains exam, you can just, if you just look at all the previous year problem only, more or less that type of questions are basically generally asked. Okay, so students who haven't a good hold on the syllabus, you can definitely try to understand that particular part, and you can prepare well for the part, right? All right, so please let me know if you have any questions or not. All right, so I'm going through your live questions. Please let me know. All right, so I hope this part is clear to all of you. So if you have any questions, you can definitely mention that. Okay, and if you're someone who is watching this session after the live is over, so you can always put the question in the comment section, and you can ask me about that, right? So let's get started on this next problem. So our next problem is here in the screen. So again, this is a very similar problem, which is basically involving the important eccentricity equation as the intersectum length, right? So again, and this question I took up because again, it is discussing about the focal distance, right? So as of the case of hyperbole ellipse, we have already seen that the focal distance problem is an important problem, right? So let us try to understand what this question is talking about. Now see, now over here you can see that the hyperbola equation is given as minus of x square by a square plus y square by b square is equal to what? Excuse me. All right. So sorry for that. So yeah. So minus of x square by a square plus y square by b square is basically the case of an hyperbola where our where our major axis major axis is the y-axis. Okay, where our major axis is basically the y-axis, right? Now it is said that is eccentricity of this particular hyperbola is square root of 3, right? And we know the eccentricity equation is nothing but 1 minus 1, sorry, 1 plus in this case the major axis is y-axis, so it is will be a square by b square, right? It will be a square by b square, right? And this is given as square root of 3. So from here I'll get the value of 1 plus a square by b square is equal to 3, right? So from this part I can calculate the value of a square upon b square is equal to 2. Now let us consider that our first equation over here, right? So we have one equation involving the value of unknown, the variable a and b. So we got one equation, right? Now, one more information is already given in the problem and in terms of length of the lattice rectum. So length of the lattice rectum is given as 4 square root of 3. So in this case, the major axis is the y-axis. So for this particular case, I will have the lattice rectum as 2 times of a square by b, right? So I will have the lattice rectum as 2 times of a square by b. So from this case, I can have the value. I have one more equation in a and b that will be basically as given as 2. So if I take square on, or if I just try to put the value of a square is equal to 2 times of b square. So I'm going to get it over here as 2 times of 2 into 2 times of b square divided by b is going to be equal to 4 square root of 3. From here, we can simplify the value of b. So we can find the value of b as simple as square root of 3. So we got the value of b as square root of 3. And if we have the value of 3 as b as square root of 3, so we can find the value of a as well as. So that is going to be equal to square root of 6. Right? Very simple, straightforward. Right? So once we have the values of a and b for the hyperbola, now we are in the position to define entire geometry of the hyperbola. Right? But it is said that suppose a point, so let that point alpha comma 6, so it is said that let a point alpha comma 6 where alpha is greater than 0 lies on the hyperbola, lies on the hyperbola, okay, lies on the hyperbola H. So from this case, you have to find out that beta is said that it is a product of the focal distances of the point alpha comma 6. Now it is said focal distances. So it is basically we're going to find out the distance of that point P from the both the focus, right? So how will I calculate that distance? So I know, so first of all, since this particular point lies on the hyperbola, so therefore I can put that in the equation of the hyperbola and solve for it. So alpha square by 6 minus, so 6 square by 3 is going to be equal to this is going to be 12 is equal to 1. So from here we basically have minus of 1, right? So I'm taking minus common. So from here I'll get the value of alpha square is equal to 66. So why have the value of alpha square as equals to 66, right? So once we have alpha square is equal to 66, now our foci or the focus, okay. So our two of the focus is basically 0 comma b into e and 0 comma minus be, right? So we have the two of the focus. So one of the focus. So if I just put it back into this equation, I will get one of the focus at 0 comma 3 and another focus at 0 comma minus 3. Now if we have the value of this point P and the two of the focus, so let us call this S1 and S2. I just need to find out beta. So beta is basically the PS1 into PS2, right? Which is basically can be simplified as square root of alpha square plus of 9 plus, sorry, multiplied with square root of alpha square. Now 6 minus of minus is going to be 9. 9 square is going to be 81, right? That is going to be my value of my beta. So from this I will have the equation as alpha square plus 9 multiplied with alpha square plus 81 and take a square root of that, and that is going to be equal to beta. So from this, if you put the value of alpha square 66, you will get this value as coming out as 105. So you will have the value of beta as 105, right? So from this you will have the value of beta, and once you have this alpha as well as beta, so you need to find out the value of alpha square plus beta square. So from this part, your value of alpha square plus beta, right? Not beta square. So alpha square plus beta is going to be 66 plus 105, and that is going to be equal to 171. So from this, you will have option number B as our correct answer for this particular problem. So unlike the question that we have already solved in the part of ellipse, where we solved the distance of the focal distances as in terms of the taking the distance from the directrix and multiplying with the eccentricity, right? That was what we did in the case of an ellipse, right? But in this case, since we are having the foci, so we can directly solve for that but just by calculating the distance formula as well, right? Now, if you want to solve it by taking the distance of the directrix and multiplying with the eccentricity, you can always do that, okay? That is totally fine, okay? So I hope you can understand this, how to solve this problem. So this problem is a really important problem. Please mark it because you have already seen that these types of problem where focal distances are involved are very important, right? So please mark this as an important problem. Okay, please star mark this problem. This is going to be very important. You have already seen question that has been repeated that on the ellipse of the focal distance. Similarly, for the case of hyperbola also, the focal distances points are also important. So make sure you study this particular part carefully. Okay, and also please don't miss out on the basics part of the hyperbola, okay, because hyperbola basics part is also very important that you can see over here, right? All the important points, all the latest rectangle length, right? The foci, the eccentricity, those important those particular part are really important, right? So I hope this is clear to all of you. Please let me know if you're not clear or okay. So you can definitely put that in your live chat. So I will be going to a live chat. You can ask me for any questions if you are having. All right. So please let me know. Please let me know if you have any questions. Okay, so I hope this is clear to all of you. So if this part is clear, so we can proceed with the next problem then. So next problem is on our screen. Now this is really an important problem. Okay, I took this problem just to show you that sometimes the questions may be more of involving in case of geometry, right? Now if you just look into this problem, nothing has been mentioned about the equations, only it is mentioned about the areas, right? So let us try to understand and figure out, because this is going to be a geometrical sense problem. Okay, so you have to figure out your senses through the geometry part over here, right? So it is said that consider a hyperbola having the center at origin. Okay, consider the hyperbola having a center at origin. So something like this. Okay, so let us consider the general equation of hyperbola over here, that is x square by a square minus y square by b square is equal to 1, right? That is our general equation of an hyperbola, right? For this case, now it is said that it is having the center as the origin and the forces are on the x-axis. So that is basically giving you the implication that your x-axis is the major axis, right? We don't call this major axis and minor axis in this case of an hyperbola. We call it transverse axis and conjugate axis. Okay, so please make a correction. So x axis is going to be the transverse axis. Okay, transverse axis, right? So x axis is going to be the transverse axis over here. So from this part, then we can further calculate. Then it is said that having the center at origin. Now C1 with a circle touching the hyperbola. Now there is a circle touching the hyperbola having the center at origin. So I can always try to fit a circle having the origin and touching the hyperbola. Then obviously this particular length will be the diameter of the circle C1, right? Because it is said in the fashion that it is touching the hyperbola as well as origin as the center. So that is only case when this particular length. So let us call this point as A and this point as B. So this is only possible when AB is the diameter of the circle C1, right? It is also said that there is one more circle C2 is a circle which is touching the hyperbola at its vertex. Vertex means this particular point B, right, or this A. So there is one more circle which is touching the hyperbola at its vertex, right? This, okay, something like this. Let us call this circle C2. Okay, touching the hyperbola at its vertex, right? And it is said that it is having the center as one of its foci, right? So let us call this one of the foci S1 and this S2. So one of the foci, let us say this particular circle has center S1, okay, over here, right? And it is said that if the area of the circle C1, so this particular circle area is given 36 pi square units, and similarly this particular area is given as 4 pi square units. So from this particular part, you have to find out what is the latest rectum of the hyperbola H, right? Very interesting problem. Let us try to understand how to solve for it. First of all, I will try to figure out the equation of the circle C1 and C2, which is very simple, because this particular, so C1 will have the radius as A, because for our hyperbola, this particular distance is going to be equal to A. So this particular circle C1 will have the radius as A and origin as a center. So I can write the center equation of the circle C1 as x square plus y square is equal to A square. And similarly, the circle C2 will have the center at a comma 0. So our this particular case of circle is going to be x square plus x square plus, so this particular case, so in this case we have the center at ae comma 0. So it is going to be x minus ae whole square plus y square, and the basically you have to find out this particular distance, right? And your distance or the radius is going to be this particular distance of this particular circle C2 is going to be this much, right? Now which is basically ae minus a. So from here you can find out that the radius of this particular circle C2 is going to be ae minus a whole square, right? So we have this particular information with us, right? Now we just need to solve for these two circles. Now it is said that the vertex is one of the point which is lying on the circle, right? So what I'm going to do it over here is that now I have the area. From here I can find out the value of a, because I know the area of the circle C1, which is basically pi into a square is going to be 36 pi. So from here I have the value of a basically equal to 6, right? Now, and from the circle C2 I have pi into ae minus a whole square is equal to 4 pi. So from this I will have the value of, a square into e square minus 1 is equal to 4, which will give me the solution as, so which will give me the solution of e, will give me e minus 1, sorry, this should be extremely sorry, this should be e minus 1 whole square, right? Let's correct it. So this should give me the solution of e minus 1 as basically equal to 1 upon 3. So from this I will get the value of e as 4 upon 3. So once I have the value of a and once I have the value of eccentricity, I am always in a position to define my b. So our b is going to be, so b square from our general equation of eccentricity of our hyperbola, b square is equal to ae square minus a square. So from this I can get the value of, from this I will get the value of b square, and our b square is basically coming out as 28. So if you just try to find out what is the value of b square, you will get it as 28, right? Now we all know the length of the lattice rectum. The length of the lattice rectum for our general case, okay, of a general circle, general hyperbola is basically equal to 2 times of b square upon a. So now we have the value of a, b and eccentricity. So we are basically going to easily find out the length of the lattice rectum, and that is going to be equal to 2 into b square, and b square is equal to 28 and a is basically equal to 6. So which is basically going to give me the answer as 28 upon 3 units, right? So that is going to be my answer for the length of the lattice rectum. So from here I will have the option as 28 upon 3 as my correct answer. So from here I will have option number A as my correct answer for this particular problem. I hope this is clear. So without even knowing the any general equation, we are also going to figure out just by using the geometrical sense of this particular problem. I hope this is clear to all of you. Please let me know if it is not clear. Otherwise, I will repeat it again. Okay. So we are, if even if we don't define the equation of the circle, we are still going to find out very easily, because once we have the knowledge about the radius of the circle, then we can find out from that, we can find out a, we can find out e, and once we get a as well as e, I can find out always b. Right. So from that complete information, we are going to define the entire thing easily over here. I hope this is clear to all of you. Please let me know if it is not clear. Otherwise, I will repeat it again. Okay. So with this, let me take up. Okay. So this part is straightforward. Okay. Just involving the simple basic concepts. Okay. The basic part that I always talking about. Right. Yeah. Hi, Vian. Right. So, okay. I get it. It's correct. It's all correct for you. Right. Okay, and if you have definitely any questions, you can always post that in the comment sections. All right, so I will be looking through your comments. Okay, now I have one more question for you as a homework problem. Now this is a very interesting problem which involves the trigonometric identities as well as the basics of the hyperbola eccentricity part, right? So if you just try to solve this question, you have to basically find out a trigonometric equation. From that particular trigonometric equation, you are going to find out the value of theta from this particular problem. I hope this is clear to all of you. So please try to solve this problem as a homework problem. Okay, so please take this particular problem as a homework problem, and please let me know the answer you are getting for this particular part, right? So again, you just have to apply the simple concept. So one of the cases you will have a hyperbola. So for hyperbola, the eccentricity is defined as square root of 1 plus, for general hyperbola is 1 plus b square by a square, and for the case of an ellipse, the eccentricity is 1 minus b square by a square for general ellipse, right? Where our x-axis is a major axis, and in this case where the x-axis is a transverse axis, right? So if we just try to apply this particular part, and we have seen, we have a equation given as eccentricity of the hyperbola is given as square root 7 times the eccentricity of the ellipse, right? So from these two information, you can easily find out the value of the theta. So I will be definitely looking for your solution in the comment section. So please let me know the answer of this particular question in the comment section. Okay, so I will be looking for your comments in for this particular problem, right? Is it clear, Vian? So Vian, thanks for joining for this session. Okay, so please keep on solving the questions along with me. All right, so let's get working on the next problem then. So let us start to proceed with the next problem, and the next problem is again a very simple problem, but I took this problem in order to explain you the concept of that if we have one ellipse and one hyperbola, that is a very interesting case, and you are going to mostly see this kind of cases in the examination. That is, they are going to mix up a hyperbola as well as ellipse both together into a particular problem. Okay, so let us try to see how we are going to proceed with this particular problem. So this question says that eccentricity E1 is defined as the eccentricity of this hyperbola. So let us call this hyperbola as h, and that is given as x square by 16 minus y square upon 9 is equal to 1, right? So from here we can simply find out the eccentricity of this hyperbola, or eccentricity that is given as E1 is basically simple square root of 1 plus 9 upon 16, and that is going to be equal to 5 upon 4, right? And similarly for the ellipse, the ellipse equation is given as x square upon a square plus y square upon b square. Now for this case the eccentricity is given as E2, right? And it is said that a is greater than b, so therefore it is very clear that your x-axis is going to be the major axis for this particular ellipse as well. Now it is said that this ellipse will pass through the foci of the hyperbola. So let us try to find out the focus of the hyperbola. The focus of the hyperbola is going to be plus minus a comma 0, which is basically going to be equal to plus minus 4 into, so 5 comma 0, right? So it is said that the ellipse passes to this 5 comma 0 point, ellipse passes the foci of this particular hyperbola. So therefore I will have an equation. So if I just need to put this back into this ellipse equation, that I will get as 25 upon a square is equal to 1. So from this I will get the a square value is equal to 25 for this case of an hyperbola ellipse, right? So for this case of an ellipse, our a is basically equal to 5. So for the case of ellipse, the value of a is equals to 5. Right now, and also I have one more information that is given as the eccentricity of hyperbola into eccentricity of ellipse is given is equal to 1. So that is from here I will get the eccentricity of the ellipse is basically equal to 4 upon 5. So once I have the eccentricity of the ellipse and I have the information about the point, the value of a, so I can always find out the b for the ellipse. So b square for the case of ellipse is basically a square into 1 minus e square. So it is basically e2 squared because it is for the case of an ellipse, right? So please make sure that you don't mismatch each of these equations, because for the case of hyperbola the eccentricity is greater than 1. For the case of an ellipse the eccentricity is less than 1. So that's how the equation will change. Okay, so the equation will change for this case of an ellipse. Okay, so from here I'll get the value of b square is equals to 25 into 1 minus 16 upon 25, and this is I will get it as equal to b square is equal to 9. So from here I have the value of b square is equal to 9, right? Now it is said that in the problem I have to find the length of the chord. Which is parallel to the x-axis, right? So I have to find out the length of the chord which is parallel to the x-axis and passing through 0, 2. So let us try to figure it out. So if this is the ellipse over here, right? So I have to find out. So this particular point is basically our 5 comma 0, and this particular point is 0 comma 3. So if I have to find out a point such that it is passing through 0 comma 2 and is parallel to the x-axis, right? It is said that it's parallel to x-axis. So I have to find out this particular length a b, right? So let us say this is the length, right? So it is very simple. So this particular equation is y is equal to 2. So for y is equal to 2, if I just put it into the ellipse equation, so for solving for y equals to 2 into this ellipse equation, that is x square divided by 25 plus 4 upon 9 is equal to 1. So from here I will get x square upon 25 is equal to 5 upon 9, and with this I will get the value of x as plus or minus 125 upon 9 and square root of that, which is simply nothing but is equal to plus or minus 5 root 5 divided by 3, right? So I will have this the 2 of the, so this a point is going to be minus of 5 root 5 by 3 comma 2, and similarly our point b is going to be 5 root 5 by 3 comma 2, right? So from this I will find out the value of AB, or the length of AB. So L of length of AB is going to be simply just 5 root 5 by 3 is just going to be equal to 2 times 5 root 5 by 3, that is going to be equal to 10 root 5 by 3, right? That is going to be equal to 10 root 5 by 3 units, right? So from this part I will get my answer for this particular problem as option number D over here. I hope this part is clear to all of you. So this is very straightforward problem, right? It's just using the concept of an ellipse and a hyperbola to solve for the problem, right? Now I have a very interesting problem for all of you, is to try out this particular problem. Now this is a very, very interesting problem that I want to make you focus upon, because these questions is always a important problem for your JEE Mains as well as your JEE Advanced, right? Now this question is, I will give a hint for this particular problem, whatever you do over here. So given an hyperbola, you just need to find out the tangent. Okay, you just need to find out the tangent which is parallel to this particular line. That's how you will get the shortest distance. Okay, so for this particular hyperbola, it is said that you have to find out the point P on the hyperbola that is given as x naught comma y naught such that it is nearest to this line. So let us try to draw the line like this over here. So if this particular distance of this point P from the line is going to be minimum, for the minimum distance, I must have the tangent at point P must be parallel, must be parallel. So this is the tangent T at point P must be parallel to this particular line that is given as 3x plus 2 y is equal to 1. So for the case of tangent at point P, I should have it basically equal to minus of 3. So the tangent at point P should be equal to minus of 3 by 2. Should be equal to minus of 3 by 2. So from here, so this is for the case of shortest distance. Okay. So for the case of shortest distance, you will always know the shortest distance always occur along the common normal. So instead of solving for the common normal, if I try to make the parallel condition of the tangents, that will also make the case simple for me, right? So from this, you'll get this particular distance as the minimum distance, right? So in order to find the point P, you can do it as by taking that point P on the hyperbola and passing the tangent at the hyperbola. From this, you will get the information about the x naught and y naught. And once you have the x naught and y naught, you can always solve up for this particular problem over here. I hope this is clear to all of you. So please make sure that you remember this information for your exam, right? This is very, very important. Okay, very, very important. Okay, so I'm putting VVIP. Okay, so this is very, very important problem. So make sure that you don't forget this problem. This is going to be very crucial. If you just look into the previous problem and you do some analysis, you will see that these types of problems are repeated many times. Okay, shortest distance problem of a point from a straight line is a very interesting problem and has been repeated many number of times. So please make sure that you don't miss out on this particular problem. I hope this is clear to all of you. All right, so with this part, we are almost approaching the end of the session over here. So if you have any questions, you can definitely ask me. Okay, all right. So yeah, fine. So, this is clear to all of you. So I am looking forward for your answer of this particular problem as well as the problem of calculating the theta. Okay, in your comment sections. Okay, so I will be looking for these two homework problem. Please let me know after solving these two questions and in the comment section. I will be always looking for your comments. All right. So with this part, let us wrap up our session over here. And if you have something, at least you got something from this particular session. I hope so. All right. So if you haven't understood anything, you can definitely post that in the comment section as well. I can definitely help you out with the queries. All right, and if you have something, at least got something, you can definitely like this video and you can share it among your friends. Okay, so I'm looking forward for your attention in the upcoming session. So with this, we are done with the CONIC section, and in the upcoming session we'll start with the part of algebra. We start with quadratic equations, then we move to the entire part of algebra part, right, till probability statistics. So that is what our next target is going to be on. So if you haven't subscribed to this particular channel, please make sure that you subscribe to the particular channel and hit the bell icon. We are going to meet up daily live in this particular channel in the time evening. All right, and we are going to discuss lot of important previous year problems, right? With this, I'm going to help you out with your JEE Mains preparation. I hope this is helpful for all of you and helped you to understand the concept nicely. With this, let us end our session over here, and thank you all. The